Okay. All right. Now, I'm sure you remember the names, right? Yeah. Okay. So I'm sure you remember the names. Okay. So traditional medicine. Okay. Modern medicine, complementary. Modern medicine, they always ask you the three: psychotherapeutic, analgesic, and antibiotic. Common questions they ask you, different kinds of psychotherapeutic drugs, and then analgesic, which one is good, which one is bad, and then antibiotic, why only for bacteria? Why must finish the course? That's the only questions they ask. Okay. Complementary is like acupuncture, physiotherapy, TCM, all that is complementary. And then traditional medicine is like the tongkat ali, ginger, turmeric, all that. Okay? Now, I've taught you before, the last chapter we went through again. Free radicals, the most famous free radicals is, of course, chlorine atom. Why chlorine atom? Chlorine usually exists as Cl2, but because of UV light or exposure to smoke or whatever, the chlorine molecule will break apart to form chlorine atom. So chlorine atom is 287. Do you remember what this is? Electron arrangement. Okay. When is it happy? Is it happy to have seven or must it have eight? Eight. So because it is seven, it's actually not supposed to exist as an atom. It is only supposed to exist as a molecule or a compound. So because it is seven, it's very kacau. Okay, it will go and disturb all sorts of other molecules and all sorts of other cells. That's why it's called a free radical. And the thing about a free radical is it doesn't just kacau one. It can kacau one, destroy it, and then come out again. And then kacau another one, and then destroy and then come out again. So one free radical can cause a lot of damage. Okay? So it lacks one electron, which makes it very unstable. So because it's unstable, it goes and attacks everything. So the most famous one is chlorine atom. Lah. Okay, can. So remember, it lacks one electron. It wants to get one more electron. So what is the antidote for a free radical? Antioxidant. So antioxidant is the opposite. Okay, so it gives the electron, say, okay, okay, I give you, don't kacau. You don't disturb anybody. Okay, so examples of antioxidants are vitamin C, okay, lutein, okay, all those things that are very colorful, vegetables and fruits that are very colorful, the red color, orange color, all of these are very high in antioxidants. Okay, so they compensate for the free radicals electrons deficiency. Okay, can? All right. Now, health products. So health products have active vitamins are also vitamin C, like I said, vitamin C, vitamin A, these are antioxidants. Okay, so they have products that will counter affect free radicals, number one. Also, they help to prevent diseases. Okay, okay, all right. Can you try this? Can you try this? Okay, do already. We did until where? Okay, one not you done. 139. Number? Number six haven't done. Okay. We finish this today lah. Okay. Can you please ask your teacher what chapter is coming out? Okay, you do number six first. See whether you can remember. Eh, where's you go? You went home early? Okay, I guess done. Done. All right. Okay, so man-made medicine is synthetic medicine is like antibiotics and all that. Okay, medicine from natural resources, it's like aloe vera and all that. Okay, so both are used to cure diseases and reduce pain. Okay, there is a risk if side effects is used without the advice of a doctor. Patients does not follow the correct dosage. Okay, can? Okay, so source is man-made. Oh. This one, the source is natural. Laboratory, can lah. All right. Okay, when you are taking, uh, stop when pain subside. If it's pain, you stop when pain subside or follow dosage by doctor. Okay, but this one is long term. You know what is 灵芝? The herb. Okay, can people take one day 灵芝 and then tomorrow 变神仙 already? No. So it's all these traditional medicines are very long term one. Okay, what is a short term can go? Oh, it's fast acting. Okay, okay. How do you know something is healing? It's clinical tests. That means they test on different they test on thousands of people, and all these thousands of people show to have less pain and everything. That's how you prove that it works or doesn't work. Okay, this one is evidence of healing for traditional medicine is what? How do you know the traditional medicine works? Experience, yeah. Okay, an example of these two. So this one is synthetic vitamin C, and this one is lemons. Okay, so synthetic vitamin C tablets, and this one is vitamin C from fruits. Okay, why am I talking about vitamin C? Because the diagram is vitamin C lah. You see or not? Okay. Do you have science class tomorrow? Can you go and ask your science teacher whether chapter 11 and chapter 12 is coming out? Because that one got a lot of calculation. If God, I need to teach you next week already. Can find out. Okay. All right. Question 7 is about antibiotics. Okay, can you do question 7, please? If not, then we finish this, then I start teaching you lah. Although I don't have the notes today, I can start teaching you about about all the what's it called velocity and everything. Teaching chapter 11. So chapter 11 coming out lah. Okay, then I start today. After we finish this, I start chapter 11, okay? Okay, thanks, Dylan. Huh? Done already? All right. What is the function of antibiotics to kill bacteria? Okay. Antibiotics that are not finished according to the doctor's prescription may cause the bacteria. to not be completely killed and become resistant or immune to the antibiotic. This may result in the patient needing a stronger dose. Okay, so this is how antibiotic resistant bacteria is actually formed. Okay. Uh, okay. Tina receives advice from a doctor to take medication according to prescription. What are the consequences of misuse? Causes addiction if taken excessively. Causes severe, sorry, what? Side effects. And can causes death. Okay. All right, last one, free radicals. Okay, can you all just finish it? Then we discuss, then we get rid of this, then we can do the next chapter. Okay? Wait, try and do that, don't sleep. Do already so fast the whole thing. Okay, come. Let's finish this. Okay? Alright. So free radicals, atoms or molecules that lack one electron. Okay? To make the atoms unstable. Okay, and tend to attack other atoms or molecules. Okay? All right. Free radicals are produced from the oxidation process that occurs naturally inside the body. When a substance loses its electron, the situation triggers a chain reaction. Chain reaction is like what I told you just now. It's not just one. It will go and attack one, and then it will come out, and then it will attack another one, and then it will come out, and it will attack another one. So it's a chain reaction. Is A causes B, B causes C, C causes D, D causes E, and then it continues. So chain reaction. Okay. So what is two examples that causes free radicals? In your body, there's something called inflammation. Inflammation is why sometimes you got headache, why you got pimples, why you got everything. What causes inflammation? Food. Okay, not enough sleep, food, food like um a bad diet lah. Yeah, it's your organs don't suddenly become inflamed. Your organs become inflamed because of what you give it. For example, twisties, chips more, Oreos, not enough water, not enough fiber, not enough vegetables. All of this causes inflammation. So it's inflammation, it causes headaches. If you have a lot of headaches, if you got a lot of pimples, if you suddenly a lot of shoulder ache, all of that is actually inflammation. Okay, can now another thing that is can cause it is metabolism. Okay, so metabolism, toxic waste, ionizing, and air pollution. Okay, sorry. Metabolism, external factor. Metabolism is internal, sorry. These three are external. Okay, all of this. So, for example, smoking. Smoking is a can cause free radicals. Okay, free radicals can form carcinogen substances that cause cancer through free radicals cause premature aging through. Free radical causes the body's metabolism to rate to be higher. False. It lowers your metabolic rate. That means you feel very sluggish, feel very tired. Okay. Uh, Infertility can occur as a result of free radicals. True. Okay. Okay, so this is what I should. This is what is stable. 8 electrons. It loses one, it becomes 7. Okay. Chemical substances that are needed in our body to okay, slow down or stop the oxidation process. Literally, the name is antioxidant. Okay. Okay. Antioxidants complete the lack of electrons possessed by the free radicals by donating their electrons to the free radicals. Thus, the chain reaction can be stopped. Okay? Is this the answer? Okay. All right. Beta carotene. Carotene is the color of carrot lah, so it's orange, yellow. Okay, lutein is the one in green leafy veg. Okay, vitamin C is ascorbic acid. Okay, vitamin E is found in oils, and lycopene is found in uh, papayas and guava. All those colorful. Teacher, guava is white color. I'm talking about pink guava. Okay, can? So all those antioxidants, those are colorful. Okay, can? Okay, so what is an example of antioxidant? This one lah, lime juice. Okay, I think we went through this already, right? Okay, never mind, never mind. Okay, so antioxidant. No, this one we went through another book. Okay, so lime juice is an antioxidant because it has vitamin C. So how do I know it's being oxidized? It's being oxidized when it changes to become brown. Okay, so whatever stops it from being brown. Can you tell me some other thing that also stops it from being brown? Okay, actually salt also can stop it to being brown. Okay, so if it's just left open, it turns brown. Sugar turns brown. Sugar is not an antioxidant. Don't feel so happy. Go back and eat a lot of sugar. No. Sugar literally causes inflammation. Okay? Sugar causes inflammation. It's really, 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 really bad. Alright? So, salt and lime juice, no change. This one turns brown. Sodium bicarbonate turns brown. Do you know what is sodium bicarbonate? Baking soda. Yeah. The one to bake the cake. Alright? Okay. Oxidation process causes the fruits to become brown when exposed to air because there is oxygen in the air. Did not turn brown after 15 minutes. C and E. Okay. Arrange the set of apple slices in order of decreasing brown color after 10 hours of soaking. Okay, decreasing. Uh, so the one that has the best one is, of course, vitamin C. The second best is, of course, salt. Which one is going to be the worst? Sodium bicarb. Okay. Sodium bicarb and then alone and then sugar. Okay. What component in lime juice? Okay. This one you don't know. This I'm going to sit down and cry. Literally, vitamin C. Or ascorbic acid also can. Alright. Or you can call it antioxidant. Okay. Solutions containing antioxidants slow down the oxidation process. Okay, the oxidation process in apples. Can? So remember, every chapter there's not many experiments. Right? This chapter not many experiments. Okay, health products. Folic acid. Folic acid is given in to pregnant women. Okay, you know how okay, let's say this is the baby. Okay, what grows first? Your brain and then your spinal cord. Right or not? Okay, so your brain and spinal cord grows inside or outside the bones? Inside. A certain condition when you're pregnant causes the spinal cord to form outside. So let's say this is the baby standing, looking this way lah. Okay, so this way. The spinal cord is coming outside like that. It doesn't fully form inside. So there's a bump like that. So folic acid is supposed to stop that. Okay, can you must take folic acid when you're pregnant lah. Okay, can I mean boys of course can't get pregnant lah. Okay, but you can get it from your daily food. Okay, what is meant by active ingredient? Okay, the specific component of the medicine or chemical that is used to prevent diseases. Okay, Okay. Active ingredients can react and harm human health. Okay. Now, for example, remember I told you this is for pregnant women? There is one medication many years ago that was given to pregnant women, okay, in the 1960s. And all the children that were born had no limbs, either no hands, no legs. Some no hands, no legs, no arms. Okay, it was a very, very big scandal. Okay. Seek medical advice. Okay, always seek medical advice. Okay, and always check the labels first. Okay, all right, we're gonna go to the right. Oh, okay. Do you have your science textbook with you? Huh? You have it? Okay. If you don't have it, it's okay lah. Okay. Now, first of all, okay, the first formula we learn is speed. Okay, speed is distance over time. I'm sure you know that lah. Okay, if someone is running at 100 meters in 10 seconds, then his speed is 10 meter per second. Okay, now what happens is when a person is running, his speed at 10 meter, his speed at 50 meter, and his speed at 100 meter is not the same. Right or not? He could be faster at 10 meter and then 100 meter he slow down already, very tired already. Or he could be starting slow and then become faster. So what happened is the total speed over the total distance over the total time, that was for our average speed. Okay. Now, what happens is there are two kinds of units. We can also do, let's say, 100 kilometers in 2 hours. So this would be 50 kilometer per hour. All right. So meter per second or kilometer per hour. Do you know meter per second and meter per second is the same thing? Yes, right? Okay. So kilometer per hour. So these are the two common units that we use. Okay. All right. Now, okay, so not okay. What is velocity? Okay, velocity is rate of change of displacement. Okay, so it's basically same as speed lah. Okay, velocity is same as speed. So that's why sometimes when we calculate speed, we use the unit of v. Okay, is how much it has moved over time. Isn't that the same? Yeah. So velocity and speed actually mean the same thing. Okay, can? All right. Okay. Okay. Do you know what's acceleration? If you drive, if you drive, right, how many pedals do you have? If it's a manual car, there's three. If it's an auto car, there's two, right? So in the auto car, the first one is the first pedal and the second pedal. Okay, the second pedal is the brake. The first pedal is the accelerator. We cannot call it gas. I know you say tekan minyak. It's not tekan minyak, it's accelerator. Accelerator is to increase your speed. Get it now? Okay, so that means accelerator is your initial speed minus your final speed minus your initial speed over time. Okay, so let's say you're driving a car. Initially you're not moving, so your velocity is zero, and then within 5 seconds, you increase to 100 meter per second. So what is your velocity? 100 minus 5, 100 divided by 5? Ui, 100 divided by 5? 20 lah. Wait. Okay, so it's 20 meter per second. Because this one is already meter per second, you divide another second. You divide some more time, so it's meter per second per second. Velocity is how fast you're going. Acceleration is how much your velocity increases. Can you see the difference? Can? All right. I'm going to give you some questions to do this. Okay, so okay, both velocity and speed, we draw graphs. Okay, all right. So hold on. Let me. So can you remember the two formulas? Okay, take out a piece of paper lah, guys. You already have paper, right? Take out a pencil lah. Try and write. Try and do. Okay, a Japanese bullet train decelerates in a straight line. The velocity of the train decreases from 50 to 42 in 30 seconds. Calculate the change in velocity and calculate the acceleration. So change in velocity is what? 50 minus 42. 8. Correct? Meter per second. Deceleration is 8 meter per second over 30 seconds. Can you understand? Okay. So why is it 42 minus 50? Because it is deceleration. So this should be positive or negative. Negative value. Okay, it should be a negative value. All right. Okay, so negative 8 over 30 seconds. So if it's a negative value, that means it's becoming slower. If it's a positive value, means it's becoming faster. Can you understand? All right, so in physics, this component is physics, you have to add a value to it. Okay, make sense or not? Can I understand? Okay, let's try one more. Okay, what happens is in this chapter, you're going to do a lot of graphs, but the graphs are very, very easy. Okay, the graphs are very, very easy. There's only two graphs that you need to remember now. The first one is distance and time. If it's distance over time, what am I measuring? Oh, velocity. Distance and time, so it's velocity. Okay, because velocity is distance over time. Correct or not? Okay, then if this one is the object's distance is increasing with time, it is moving further away from the starting point. Correct. Okay. So this shows that he is moving in a constant speed or a not constant speed. Constant speed. Because every second he's moving at the same distance. Okay? So this is showing a constant speed. If the constant speed is zero, the line will be horizontal. Meaning 他不要走了就这样啦，他不要走了，就 flat 啦。That means time is going but there's no distance. Okay? Alright. If I show you two graphs, person A and person B running, who is running faster? A is running faster. Okay, remember this is a distance over time. Okay. If the person is moving faster, the gradient will be more. If the person is moving slower, the gradient will be lower. Alright? Okay, what is this? Constant speed or not a constant speed? Not a constant speed. This means that the person is moving but he's getting very tired. That means he's walking slower and slower and slower and slower. This one, he's walking faster and faster and faster and faster and faster. Make sense? Okay, so you will be given graphs and then they will ask you questions. Okay, now, how do you use this graph? Okay, basically, this gradient, did you calculate gradient in, did you calculate gradient in school? In math? X over y, do you calculate gradient? So if this is distance and this is time, then the gradient is the speed lah. Because the gradient is distance over time. Make sense? Okay. Okay. Alright, calculate the speed of this train. Can you try? What is the speed of this train? Okay, what's your answer? What's your answer? It's either kilometer per hour or meter per second. Right or not? So now this is 8 kilometer. And then the time is 6 minutes. 6 minutes is how many hours? 6 over 60. So 0.1. So it's 80 kilometer per hour. Get it or not? You cannot just you cannot just use the unit you like. Okay? Make sense? Okay, so remember it's either kilometer per hour or meter per second. Okay? Right. Now, although we call it distance, when you are measuring velocity, you must say the word displacement. Why? It's a physics term. Okay, it's a physics term. All right, Ken? Okay, so you either call it, this one is 22.2 meter per second, also can. Okay, if you want to change to meter per second, then you have to change the timing lah. So just now I did kilometer per hour lah. Okay, a student decides to take a stroll in the park. They find a bench in a quiet spot, take a seat and read a book on black holes. After some time, The student realizes they lost track of time and runs home. A distance time graph for the trip is below. Okay? You understand the question? He takes a stroll, they find a bench, take a seat, and then run home. Okay. How long is he reading the book? Okay, look at this. How long is he reading the book there? From here, from 25 minutes to 65 minutes. Can see? Okay, because here the velocity is 0. Okay? Which section is running home? C. What is the total distance traveled by the students? 0.6 kilometers. Can see? Okay, 40 minutes, yeah. Okay, all right. Now, here's the second graph. Speed time graph. Okay, speed time graph is to measure acceleration. Okay, just now is distance over time. This now is distance over time. So here he's moving. Here he's not moving. And here he's running. Understand? Okay, that's distance and time. Okay, now we're going to do speed time. Okay, if in a distance and time it is flat, if it's distance and time and this part is flat, 这边还有动还是没有动？没有动。But if it is speed and time, 它这里有动吗？有。It's just he's moving in a constant speed. Okay? This is deceleration, moving slower and slower. This is acceleration, moving faster and faster. Can you see the difference? Okay? All right. Okay. Here's the thing, if it's speed over time, okay, if it's speed against time, the area of the section, if it's this one you learn in maths, right? Okay, so the distance is the area. How far he travels is the area. Okay, do you know how to measure area now? Ah, if it's a triangle, it's half base times height. If it's a square, then it's base times height lah. Okay, can. So that equals to the that gives us how far he travels. Okay. Why? Why does it give us how far it travels? Because speed is meter per second. You multiply time is second. So meter per second times second is meter lah. Okay, so this multiply this, the area below here gives us the distance. Okay, can? All right, the only way you can do this is by doing a question. Okay, look at this question. Calculate the total area that is traveled by this car. Okay, are you counting? Come on, come on. You can do this. Total distance traveled by the Which one? The 40-second mark. Alah, 17.5 lah. So you need to count here plus here plus here. Wah, bagus lah Josie. Okay. Finish ah? Which one ah? Seven half multiply 17.5 times 40. That's here. This one and this one, just add the two together lah. This is 110. 110 minus 40 is 70. Ayo. 70. So add 70 multiply how much? 17.5. Add this triangle and this triangle. Okay? Can see it or not? Okay, add it all together. Okay, so area 1, 2, 3, 4, 5. Okay, did you manage to count? What's your answer? Finish? Who's not? It's just maths. Okay, your final answer 2,175. Do you get that? Okay, obviously you did something wrong. Okay, the first you should get 2,175. Measure it out. You want to try again? Try again, try again. No, you must be able to count. This is just maths, okay, guys? It's just maths. Try again, try again. They even give you the area already, ma. 你要写起来，人家看不到的，要写起来。 对，收到了没有？Hello，有吗？收到没有？2175. Your area 350, 525, 75, 350, 875. Okay, your first area is here, area 1. It's 40 times 17.5, but it's half ma, because it's a triangle. Your second area here is 40, sorry, it's 40 to 70, so it's 30. 30 times 17.5. Okay. Your third area is the triangle here, the small triangle here. All right. So this is how much? You take 25 minus 17.5, multiply, here's only 20. And then finally, your last one is your big area. Get it or not? So you should get, first one is 350, second one is 525, third one is 75, and then fourth one is 350, and last one is 875. Do you get it? 算到吗？还是收到了，OK good，收到了，OK 收到了，OK good. So remember the three graphs, okay, let's look at these graphs. This is speed against time. So is it it's called an acceleration graph. So is it constant acceleration? Yes, constant acceleration. Okay, what about this? Increasing acceleration. That means I'm driving faster and faster, F1. Okay, this one is decreasing acceleration. I'm driving slower and slower. Here, does it mean I stop? No, it means I'm at a constant speed. Don't confuse it, I'm at a constant speed. Okay? This means what? I'm driving slower and slower. Okay, I still haven't stopped. I'm just going slower and slower. Can? Right? Okay. Just now, if I want to calculate speed for the graph, so there's only two graphs. This one is distance against time. Distance against time. The gradient is my speed. Okay. The second graph is speed against time. The gradient is my acceleration. Can you understand? This is my acceleration. The gradient is my acceleration because it's speed over time. Okay? Okay. This is a cyclist. Calculate his acceleration. Okay? Okay. At which section A, B, C, or D is the acceleration the largest? D. Then the most steepest is the fastest acceleration. Okay? Calculate the cyclist acceleration between 5 and 10 seconds. Between 5 to 10 seconds, what's his acceleration? Come, come, come. It's the gradient what? Remember? The x. Ah, this is 5. 5 seconds is from here to here only what? Get it or not? Get it or not? Okay, let's try one more. Okay, this is what? This speed is becoming faster or slower? Slower. So if I want to find this, it's not a straight line. So I must calculate my gradient. 这个你们有算过吗？在学校做数学的时候，用尺这样子算，有画过吗？没有啊？Maths 没有学啊？I don't think it's so. It's like this. You calculate, you draw a tangent on the thing, and then you find your x and y, and then you take x divided by y, y divided by x. You never found this before in school? 没有，数学没有学过，有吗？一定有的吗？Okay. Next week, please bring ruler and everything will count. Okay. Let me give you some questions here. One question again. Okay, let's do these 2 questions. All right. Okay, look at question 1. If you don't know this, we sit and cry, okay? How do you count? 哪里可以？喂，meter per second, meter per second, meter per second. So 60 km is how many meter? 20 minutes is how many seconds? Times? Sorry, what? See, yeah. You take 6,000, 60,000 divided by 20, divided by 60. Yeah. Ah? 50 lah. C. Oh, I heard you say B. Sorry. 50 meter per second. Okay. Right. I heard you say B. Get it? You must change it to the correct unit. Okay. 2 runners take part in a race. The graph shows the speed of each runner changing with time. Okay, speed speed. Which graph shows the runner at T? It's so obvious. Oi, what's the answer? So obvious. Hey, lah, same speed. Literally same speed. Oi, same spot. Ah, yeah, 不要想这么多。T same speed 吗？ Right or not? Okay. Okay. The graph shows how the speed of a van changes with time, part of its journey. Speed, speed. Which one is he decelerating? B. Correct. Because it's going down. Okay. 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 Uh, an object moves at a constant speed for some time, then begins to accelerate. Okay. Okay. Wait. Constant speed for some time, then accelerate. Distance time graph.
Oh, A，嗯
A 是还没有动嘞，这个是 distance over time。A 从这里到这里是还没有动C 明白吗？Can see it or not? Can you see it or not? This one is distance.
，future distance and time 的 graph bus curve down。
No，因为这个它在 constant speed，这里它 constant speed，所以它是 straight line。这里它在 accelerating，所以它 curve 上去。OK，看这个不可以，这个还没有动。This is distance over time, not speed against time. Okay, last one, last one. Okay, if you can do this, you can go home. No need to use calculator one. No need to use calculator. Which one? What's the answer?
Wrong。
它60 kilometer per hour，它跑15 minute，15 minute 几个 hour？
是
15 minute 15除什么？
60。
除60啦，15啦，get it 啊？Okay, never mind. This is new to you. Next week I print 算到你们爆炸 okay? Alright, but you must remember today we only learn two graphs. Distance against time and another one is speed against time. Speed against time is acceleration, distance over time is velocity. Okay? Can? Correct. I see that.